Hello, welcome to a tutorial on how to use the probability calculator from GeoGebra, which is a mathematics software accessible online. In this video, we're going to talk about how to find a z-score when you're given a probability. This is called an inverse standard normal distribution problem. It's inverse because we're given the probability and we're trying to find the z-score instead of being given the z-score and finding the probability. To do this, we're going to need to use this probability calculator, which can compute inverse functions as well. If you don't know how to access this probability calculator, watch my video about finding probabilities with the normal distribution. All right, let's look at two sample questions concerning this. We're given an area, which is a probability, and we want to compute C, the z-score that corresponds to this statement. The probability that z is less than c is equal to 0.4. We will also consider the situation when the probability of z is greater than c, in this case is 0.3. So, to do this problem, what we want to do first is to figure out the correct shading. What this is asking, ultimately, is it's saying, what z-score, what is the point where the probability that is, in this case, underneath that point is equal to 0.4. It's saying, I'm going to change this value here is my possible c. I want to know where on the normal curve do I need to place this arrow so that the area shaded is equal to 0.4. Because this problem is saying z-scores is less than c, the shading that I want to do is going to be the left of the value. Remember, when we're working with the normal distribution, we have four options. We can shade to the left, we can shade to the right, we can shade between, and we can shade outside. These are these four buttons on the probability calculator. So in this case, because I'm interested in z-scores that are less than a given value, remember that this axis is describing the z-scores. So I want a z-score less than a given value. That means I want the z-scores to the left of a given value. I want to be shading the left of a value. And again, I want to know where do I need to put this arrow so that the shaded area is equal to 0.4. That is what this is asking. C is this point here. What does C need to be so that the area underneath it is equal to 0.4? To use our probability calculator, the first thing what we need to do is make sure that we have it set up correctly. This is talking about normal distributions, so it's good to confirm that indeed normal is selected. And because it is the standard normal distribution, because we're talking about z's, we need to make sure that our mean, signified by mu, is equal to 0, and our standard deviation, signified by sigma, is equal to 1. So we're good here. This is the default, but it's good to check. So, because it is less than, I want to do less than, area to the left, so I'm going to select area to the left. And I know that I want that area to be equal to 0.4. So I'm going to double click on this area, the part outside on the other side of the equal sign. The P is telling us the computation. This is my z-score. Outside the equal sign is my probability. And I'm going to delete the information that's there and type in 0.4. And there we go. Here's our answer. We're going to need a z-score of negative 2.53347, etc. That would ensure that the area would be exactly 0.4. To do this particular problem, it tells us then that we need to round c to one decimal place. So rounding negative 0.25 to one decimal place will be negative 0.3. So I need to move it to negative 0.3. This shaded area is 0.4. Let's do the other example. If now we're asking for the probability that a z-score is greater, or find what value c I need to choose so that the probability of a z-score being greater than that value is equal to 0.3. Again, this means that I'm trying to find some point on this distribution, some z value, so that the all the z values above it, the proportion of z values above it is equal to 0.3. Because this says greater than, I'm going to need to be shading to the right of a value. I want all the z-scores that are greater than this value c. Greater than means to the right of. So I'm going to use my normal probability distribution function. It's normal, the mean is 0, and the standard deviation is 1. That ensures that it's a standard normal distribution. I need to be looking at area to the right because this is saying greater than, and then I'm going to click on my probability here, and I know I want my probability to be 0.3, so I'm going to type in 0.3. There we go. The z-score that will make the probability be 0.3 when we're looking at areas to the right of it, that z-score is 0.52444. In other words, for a z-score of 0.5244, the probability that a z-score lies above 0.5244 is 0.3. This question asked me to round to 1 decimal place, so 0.52 rounded to 1 decimal place is 0.5. I will move my cursor here, and this is the answer. The area here is 0.3. I have found the value c, which is 0.5, such that all the z-scores larger than that 0.5 is equal to the area 0.3. So, to summarize, when you're doing inverse standard normal distribution problems, that means that you are given the probability and you are trying to find the z-score that makes the statement true. The first thing you need to do is figure out what shading you should do, which is based on what the inequality is. Greater than means to the right of, less than means to the left of, because we are saying z-scores smaller than, z-scores larger than. Once you've figured out the shading, you select the correct shading, then you double click on the outside of the equation after the equal sign, enter in the answer you want, and your desired z-score will show up in the other box. Hope this helps.